Hi, so in part one, we were discussing this card game problem and we found out that there are 14 such cards which will make player B win, and out of total 49 cards, so the probability of winning is 2 by 7. Now we are doing a very popular probability problem which says that there are rare diseases that occur in only 1% of the population, maybe corona, right? So there is a test that yields positive results on 99% of ill people, right? So this is true positive. So those who are really sick, 99% of the time, my test is going to declare them sick. 1%, yeah, it may not. And those who are healthy people, there are 2% chances that it will declare them corona positive. So the test shows positive result on a patient. The test is showing that the patient is corona positive. And what is the probability that patient does not have COVID, right? Okay. So let us assume that we tested 1 million randomly selected people, right? Using the numbers from the problem, can we just approximate how many of them are actually ill, right? So how do you find out that how many are actually ill? Because you tested 1 million people, and your test is going to uh, tell 99% of the time the correct uh, you know true positives, and the disease occurrence rate is 1% of the population. So what is 1% of the population? For example, for 1 million, it will become so it's not 1 million, it's 10 million. So it's sorry. So we did test 10 million people. So 1% is 1 million. So so how many of them are ill? So let me correct it. Uh, Let me correct it to 1 million only, so that the 1% becomes 1, 2, 3, 4, 5. Right. So it's like 1 lakh people, 1% are actually ill. Consider people who are not ill. How many of them will be tested positive? So now how many are not ill is 90,000 people, and how many of them will be tested uh, positive? So there is 2% chance that they can be tested positive. So 99,000 multiplied by 2% is 19,000, right? So you can see that here. So this is when we do 99 multiplied by 2, so which becomes 198, right? So that's how you get 19,800 people who are actually healthy, but you will test them positive in a 1 lakh people sampling. So this indicates a huge number in 1 lakh people if you have that kind of a test, right? Then you have uh, mm, uh, consider those who are sick. So how many are sick? 10,000 are sick. How many of them will be tested positive? 99%. So 9,900 people are going to be tested positive. What is the overall number of people who test positive, and how many of them are ill? What is the probability that random person who tested positive is ill? So let us use Bayes theorem out here, and right. So let us use the Bayes theorem out here to solve this particular problem. So the problem here, it is very much important to understand that this exercise is related to probability, especially conditional probability. Assume that we have a random experiment, one person from the population randomly chosen, and the result is something like this. So when we say H1, when this person is ill, and right, and H2 when this person is not ill, right? We have a probability of A when this person is tested positive, and so now the problem statements are like, first one is when we wanted to find out how many people are ill is probability of H1, is probability H1. Then you have how many people are healthy is probability of H2, and then you want to find out probability given that the person is sick, that he is tested positive, and then you also want to find out probability that the given person is healthy and he is tested positive, right? So you can find all of them with the similar analogy that we have done here. Okay, now another problem. Suppose a coin is tossed and it comes head with a probability 2 by 5. What is the mean and variance of the distribution that is expressed as a number of times the coin comes up head in 5 tosses? So obtaining heads on a coin flip follows uh, a binomial distribution, which is given by this particular expression of head. So which is a binomial distribution, which is having a mean n and a probability depending upon number of times you are tossing n, and the probability 2 by 5, right? So h ref is, what is h? Obtaining heads, and n refers to the small n refers to the number of coin flips. So the expectation for this binomial distribution after 5 tosses is given by expectation after 5 tosses, and for n is equal to 5 you will get np as the expectation. So this is binomial distribution formula. Expectation is np. So if you are doing 5 tosses, you multiply 5 by 2 by 5, which is the probability of coming head, and you get the answer 2. Now the variance formula is given is np np into 1 minus p. This is the formula for variance. So you do np 1 minus p, and 6 by 5 is np. In the last question, we can think of simple definition of Bayes rule. So what is pxy as per Bayes rule? The pxy is p, py comes in the denominator, and this is which is also equal to px intersection y in the numerator, which if we want to write in as a conditional probability, probability of y given x multiplied by the probability of x. So here this numerator is nothing but your total the favorable outcomes in the total sample space, right? Okay. Thank you so much.